I'm ready. Can I go? Welcome to video 11.6c. We're going to look at some examples for finding the area of a sector and the area of a segment. Okay, so our first example 3 here says find the area of a sector with a radius of 12 and a 45-degree arc. So let's draw a little picture here so we can visualize it. Right? I need a sector, so it looks like a piece of pie. I know my radius is 12, and this arc here is 45 degrees. So if you remember from our formulas, the area of a sector is a fraction of the area of a circle. So I'm going to start by finding the area of the circle, which is pi times radius squared, and then I'm going to work on the fraction. We're going to make the fraction out of the entire circle, which is just the 360. And then to get the fraction, you use the measure of your arc that goes with the sector, which is 45. Now I just have to simplify. 45 over 360 reduces to 1/8 pi times 144. I want to leave that as an exact answer. So that would be 144 pi over 8, which reduces to 18 pi. Okay. The second example is a segment. It says the measure of the arc of a segment is 90 degrees. The radius is 10. Find the area of the segment. So let's start with a picture again. I'm going to make a circle. I know a segment is built off of a sector. It's from that chord to the arc. The pieces I know, right? The radius is 10. And the arc here of a segment is 90. So this right here is 90 degrees. All right, so the area of a segment, if you recall, we said we're going to take the area of the sector and we're going to subtract the area of the triangle. All right, so let's start with the sector. The sector would be this shape right here. All right, so just as we did a minute ago, I'm going to take a fraction of the circle. So the fraction will be out of 360. The arc that goes with that sector is 90. So it's a fraction of the area of a circle, pi times radius squared, and my radius is 10. That would be the sector. Now I need to work on the triangle. Here is my triangle right here. The triangle is usually what makes these problems challenging because each triangle you're going to work with is going to be a little different. In this case, right, it's going to be isosceles, but more importantly, because this arc here is 90, I know my central angle has to be 90. If you recall, central angles are the same as the arcs they cut off. So now I realize it's not just any old isosceles triangle, it's an isosceles right triangle. So earlier in this chapter, we worked with triangles. So I'm going to redraw it here separately. There's my 90-degree angle. This is 10, and this is 10. And if you recall, area of a triangle is 1/2 base times height. Well, my base could be 10 here. And my height is 10, so that is 1/2 10 times 10, which comes out to be 50. So if I simplify here, 90 out of 360 is 1/4 pi times 100. 100 divided by 4, that simplifies to 25 pi. That's my sector. And then I'm subtracting my circle, which came out to be 50. This is how we would leave it in exact form.